In this lesson, we're going to talk about cross-site scripting and how the MVC framework tries to prevent it through the use of the anti-forgery token. So if you take a look at the scaffolded code, we're going to start in the edit.cshtml. So we're in Views, Products, Edit. And if you take a look near the top here in line number 12, you see that there's a helper method called add.html.antiforgeryToken. Furthermore, if you take a look at the productscontroller.cs and you scroll down to the post version of the edit action result method, you'll see here as well that there is a attribute called validate anti-forgery token. So if you actually run the application and we go to the edit page for one of our products, let's go for the edit the bar, and we take a look at the source, we can see here way off to the right hand side, right after the form tag, there is another tag. It's a hidden input called request verification token, and its value is this big long, I guess it's a GUID. It's probably some sort of GUID plus something else added to it. Okay, so it looks like some sort of encoded value actually. So the cross-site request forgery is a technique that a malicious website could use to make a request of some widely used service on the user's behalf without the user's knowledge. So it's a different take on cross-site scripting, or XSF, which is known as one of the web's inherent security challenges. So as a hacker, I could offer some free game download on some shady website. Now, whenever you click the download link in the JavaScript on the download page, I could quietly make a request out to some well-known service on your behalf. Perhaps to a banking website or a social networking site or some website that keeps your personal details or payment information stored. So I'm counting on at least some people having logged into that well-known service recently. Now, if you don't use any of those services, then it'll just, the request will just be ignored. But if you happen to be already logged into your bank or into your Facebook account, theoretically, if they didn't have any protections of their own, then I might be able to do something on your behalf without you knowing it. So to the well-known service, it looks like you're back to begin a new transaction, maybe transferring money or whatever the case might be. However, it's me, the wily hacker, that's beginning a new transaction, and you are none the wiser. All right, so to demonstrate this, I've got a little project. Now, unfortunately, it's a little anticlimactic. I created it a couple of months ago, and apparently something about Internet Explorer has changed since I created this example, but at least you can get kind of the idea of where I'm going with this. There's a lot of different ways to pull this off. It's not just the technique that I'm using here. This is actually the simplest technique that I could come up with. So actually, let me run the application. I'll pretend that I'm a user of some well-known website. So here we'll go to my banking website, and I might even decide to transfer some money. I have $100 available in my account. I will go to home/transfer to transfer some money to a friend. I'm going to send that money to user Bob, and I'm going to give him $10. All right. So now I'm logged in currently to my bank's website, and now I decide, hey, I'm going to go download some shady software. So I'm going to go to hacker.html, and I can click download this game for free. And when I do it, behind the scenes, I'm making a post, an HTTP post out to the banking website to transfer money to a different account. All right. And ideally, if this had actually worked, you would have gone to a different page, and then when we come back here, you would see that some money has been transferred out of the banking website. But again, apparently, my Internet Explorer no longer allows jQuery's post method to actually work like that. Maybe there's some new setting. I'm not really all that sure, but you can see where I was going with this. Essentially, here in the on on the hacker.html page. I am listening for you to click this download now button, and whenever you do that, then I'm going to call the post. I'm going to say, hey, transfer some money to my hacker account, transfer $100 to my hacker account, and then I would when successful, then transfer you to hacker success, which might be, hey, downloaded success, you know. But in the meantime, I'm in the background making this post out to this URL. Since you're already logged in your bank website, I'm taking your money and transferring it to my account. Okay, so admittedly this is a contrived example, and this again isn't the only way to perform a cross-site request forgery, but it does illustrate the basics of the workflow that we're talking about and how this works. Most well-known websites actually guard against this sort of thing, but it's possible that a hacker could discover a weakness that slipped through the cracks during a security review, and then that hacker attempts to exploit it. So there are actually a couple different ways to prevent this sort of thing. First of all, you can check that incoming requests have a referrer header that's referencing your domain. So this will stop requests unwittingly submitted from a third-party domain. However, some people disable their browser's referrer header for privacy reasons, and so attackers can sometimes spoof that header if the victim has certain versions of Adobe Flash installed. Admittedly, this is a weak way to actually try to prevent this from happening. The other way that you can try to prevent this from happening is to put a user-specific token as a hidden field in legitimate forms like we've done here with the use of the anti-forgery token helper method, right? So if, for example, this token is the user's password, then a third party can't forge a valid form post because they don't know each user's password. However, ideally you wouldn't use a password as this token. You would use some random value like a GUID or some encoded value like we have seen here with the anti-forgery token when we looked at the view source, which you've stored in the visitor's session collection or into a cookie. Now ASP.NET MVC makes it really easy to do this like we've just seen by calling the anti-forgery token method and then adding that attribute. So it provides an HTML helper method and an attribute that together will generate and validate that the request, the post to the edit action result method was generated by the legitimate form, not by some hacker. Okay, so in other words, there's no way that the hacker could generate that the correct hidden input field value that our application is expecting for that particular user. So that HTML helper method, the anti-forgery token method, actually does a couple of things. It creates a new token for every request. It adds the token to a cookie on the request, and then it adds the token to the hidden form field. So when the form is actually then submitted, both the cookie and the hidden form field are posted along with all the other form fields back to your server. And as you know, cookies are sent with each request once they're written to the user's hard drive. So it's going to automatically be sent no matter what. So then if we take a look here in the products controller at the line number 116 on my screen, this validate anti-forgery token attribute compares the cookie value and the hidden form field value prior to executing this edit method through the use of something called a filter, and we're going to learn about filters much later on in the series. And so if the cookie's value and the hidden form field value don't match, then the action method will not execute. So the reason this works is because of how cookies work. Cookies are sent with each request and can only be accessed by JavaScript running on pages that originate from the same domain as the same domain name as the cookie is coming from or that it was saved to. So since the malicious hacker can't access those cookies, he can attempt to go ahead and try to construct that crazy encoded value that's being used as the token, as the anti-forgery token, but chances are they're not going to come close to that, and this this check right here using our validate anti-forgery token will see that the cookie they sent and the cookie and the value that's embedded in the hidden form field don't match, and it will just ignore that request. So this is really cool, but there's still a couple of issues that you need to be aware of, things where this will break down and not work for you. First of all, if the user doesn't enable cookies, then you're not going to be able to use this on your website. Secondly, this only works with posts, not gets. So if you are constructing your URLs or URIs correctly, RESTfully, then this shouldn't be an issue. But if you've got a get doing some sort of write or taking some sort of action which is against the kind of the rules of creating RESTful APIs like we'll learn about soon, then you're going to have an issue. The third thing you need to be aware of is that if you have an existing cross-site scripting hole in your website, in your application, the hacker might be able to gain access to the cookies for that domain anyway. So one typical XSS hole, cross-site scripting hole, is allowing a user to post text, perhaps comments, into a blog post, and if the comments contain malicious JavaScript and your application does not encode or filter this type of content, then the JavaScript could run on that page, providing the hacker access to the cookies on that domain. It's a long shot, but it is possible. And so the last thing that you need to be aware of, number 4, is that this approach, using the anti-forgery token, relies heavily on the browser enforcing cross-domain boundaries through what's known as a same origin policy. So if the end user is using a seriously out-of-date browser, then all bets are off. This isn't going to work. So in addition to this, you might decide to perform some sort of browser sniff where you figure out what browser the user is using, and you might tell the user, look, you need to update your browser or else you're opening yourself up to a potential security issue. But these limitations notwithstanding, if you take the proper precautions, the anti-forgery token features of ASP.NET MVC will go a long way towards protecting your websites from cross-site request forgery. All right, hopefully that makes sense, and you want to make sure to add these to any form that you're creating on your MVC website. Make sure that the post method has the correct attribute and that you're making a call right after you begin the form to the anti-forgery token method. Okay? All right, so now we're going to continue on and we'll talk about some of the stuff we've never talked about before, like adding this on the end of many of the calls out to the HTML helper methods. What is this all about? We'll talk about that in the next lesson. See you there. Thanks.